Try number 55. Go back to 7.2. You can put them at the end of homework. That's totally fine. I'm just having you guys go back and review because a lot builds in this chapter. But do you guys see an EC? It's not extra credit. It's normal credit. Okay? It's not extra credit. It's normal credit. So if for any reason you guys were skipping those, you need to go back and fill them in. They're not extra credit. They're normal credit. All right, here we go. Number 8. Joop, 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 joop. No, yes, no, no. Right? No, yes, no, no. Not a solution is a solution. Not a solution, not a solution. Number 12, final answer is, this is a consistent system with one answer. X is 2, Y is negative 3, and Z is negative 2. Number 22, one solution, only 2 variables. What? One solution, only 2 variables. So our system doesn't break down. It's just easier. All you had to do is R1, R2, eliminate the X, and automatically you have your row echelon form and you can solve. So it's actually simpler. Just showing you how else we could have done a 2-variable system. Like we can't do substitution, we can do elimination, but we can also do row echelon form. Thinking forward to our calculators and how they were programmed to do matrices, they can do this process to systems of any size. Number 30, inconsistent. That's the one that no, that's not the one we saw. Inconsistent, no solution. You got a false statement when you were looking for Z. It was, check out 44. Sorry, number 30 was on the second homework. Yeah. So check out the second homework. Yeah, I just put it all in one, sorry. Do you guys find it? Number 44, homework 44, number 30. Inconsistent, no solution. Thanks, Johan. Number 42, I think this is back to homework 43, right? Number 42 was the end. This is the one that we worked through on Friday. Yeah? So hopefully we were right. Make sure that we were. Negative 1/2 A plus 5/2 was X, 4A minus 1 was Y, and Z was A. I think on Friday, didn't we also write it 5 minus A over 2? That works also. But either way. But it matched. Perfect. Now we're going to homework 44, I'm pretty sure. Isn't 50 in the next homework? Homework 44. All the evens from here on out are there. Ooh. Did you guys realize how to set up the system? They gave us 3 points, and weren't each of these X's and Y's? So once you had the X's and Y's, you needed to come to your equation and plug in X is 0, Y is 3. When you plug in X is 0, Y is 3, you end up just with C equals 3. When you plug in X is 1 and Y is 4, plugging in 1 and 4, you end up with this equation. And then when you plug in the last one, 2 and 3, you end up with this equation. Now, they didn't really do this as a computer program. They kind of did this just in their own creative way because they're like, well, hey, if I know C, let's plug him in. If I know C, let's plug him in. So they went ahead and made their own little baby system. But you guys could have also used our procedure or our process. But the first step was plugging in X's and Y's. I can't get rid of the box, but that's okay. When you solve your 3-variable system, A was negative 1, B was 2, C was 3, plug it in. And if you guys went to your graphing calculator, you should have been able to check, hey, is the 0.03 on it? Is the 0.14 on it? Is the 0.23 on it? That's checking. It's looking to see if those points were on it. And they all were, if you got the right equation at least. Number 64. Ooh. Did you get the right system? Did you guys have to make the system or was it given to you? You had to make it? How did we do on that? Let's pause for a second. The math was a little tricky because of the big numbers. But let's go peek at number 64 and even number 50. Because wasn't it right around here that you had to start finding the systems yourselves? Right? So for number 47, 48, I gave the hint on Friday that for those ones, wherever he is, here he is, you were going to have to take your clues, take your X's and Y's or your T's and S's. You're going to have to plug your clue in to get your equations. That's exactly what you needed to do here on 47. You had to plug in when T is 1 and S is, and then your A, your V, your S were missing. You would have plugged in the other two clues. You could have gotten 3 equations. Down here, number 50, the one we just peeked at, 3 clues. You had to plug in the 3 clues separately to get your 3 equations. There's your system. The one we're looking at right now is number 60, right? How'd you guys get your 3 from 60? Oh, it wasn't 60? Yeah, 64. Oh, the geometry one. So how'd you get all your equations? Did you guys do x plus y plus z is 180? Good. Did you do x plus 1.5z plus 3 is 180? And 1.5z minus 11 plus y is 180? Okay. What do you do with that information? Write it nicely. Well, wouldn't you have subtracted the 3 and added the 11? That's what I would have done. And then put your x's and your y's and your z's. That's what I would have done. Then could you have eliminated your x's with R1, R2? And gotten y's? Then you would have had, actually, you already had this one. You could have gone to eliminate your x's, but you already had another y equation. So you could have taken this y equation and that y equation. You could have taken R4 and R3 and eliminated y's. Then you could have had your system of equations. And they wrote it kind of weird. I probably would have written this guy first. Then I would have written this guy second and probably that guy third. But there was some creativity in this problem because it would be a lot easier if, and you guys aren't computers. So they went about it a few unique ways, but at the end of the day, you ended up with 36 for x, 36 degrees, 50 for y, 94 for z. You could have always plugged back in and made sure it worked as far as your clues. So setting it up probably wasn't so hard. It was more the numbers that you guys might not have liked. But I think that's our last even. So help me out. Let me know where you got stuck. What do you want to see? Okay, Kathleen. 59. Anything else besides 59? Tony. 47. Gavin. Okay, let's start back at 43 just because it's the beginning. As far as like the earliest problem. Number 43 was a system that was given to us, and what was weird about number 43? Right away. Got it. So if you, because you should always have your notes nearby, right? If you had gone in your notes and looked to see, wait a minute, did we have an example like 47? Yes. And so what did we say to do on Friday if there are only 2 equations? Do we still start our system? Yes. When we have a first equation, we have a second equation, but what do we do for the third equation? Let z equal a. Let z equal a. So as I'm back here in homework, let's just double check really quickly that we didn't make any mistakes along the way. But what's the very first thing I would still say to do? Eliminate x's with R1 and R2. So x variables following our system. Double check my work, guys, because I'm going to go fast. I would have multiplied that first equation by 2. Is that what you guys did? Then we would have gotten 3y plus 2z equals 3. Looking good? Okay, but we don't have an R2 and R3, so now we're stuck. But we're not stuck because don't we have something for the first equation of row echelon? Divide everybody by 2 and we get x minus 3 halves y plus 1 half z equals -1. We can break him down to get a leading coefficient of 1. Don't we have something for the second equation? What am I going to divide everybody by? So 3y over 3 is y. 2z over 3 is 2/3 z. And 3 over 3 is 1. But where am I stuck? So if there is no z equals, what do I put? Because there must be infinitely many solutions. A. Now let's just go back and substitute. Does that make sense? So then, read x and y. Got it. So if I go back, Gavin, do you see that y would be 1 minus 2/3 a? If I plug in a for z and I subtract it. And it's going to take a little bit of work, but so distribute, combine, move to one side. Does anybody have that final solution for x after you plug in and solve? Thanks, Tony. But guys, that would take some time and effort to do, right? Because you're going to have to plug in the 1 minus 2/3 a for y. But we have plenty of examples of that in the sense of not being afraid of fractions, distributing, combining, moving to one side. Process makes sense? Questions on the process? Okay. After number 43, I think was number 47. Why didn't we like him? Because we had some work to do. So I'm going to take number 47, guys. I'm going to go straight to our notes. Some of you might want to come to your notes and fill this in. Some of you might just want to pay attention in your homework spirals. But we didn't actually do this problem or do number 48 on Friday. So let me go ahead and just say, all right, let's do number 47 instead. Given 3 positions, what do we get? So taking this example for number 47, I apologize. Our 3 clues that they gave us were the following. Our 3 clues were 3 different positions. 1, 128, 2, 80, and 3, 0. Just like with the parabola, they gave us 3 clues. I'm going to take these 3 clues and I'm going to plug them into my big equation that they said to use. Now, just to make it a little bit easier on myself, I'm going to actually read is equal to 1/2 at squared plus vt plus s. I'm going to take out those little sub-zeros because they make it a little bit harder to write. But I'm going to plug in each of these clues. The 1, 2, and 3 will go in the t spot, and then these ones will go in the s spot or the y equals spot. So it's like we have x's and y's. So when I go to plug in, I'm going to have my first clue, 128 is my y. Y equals 1/2 a times t, which is 1 squared, plus v times t, which is 1, plus s. My next clue. And now it's time for me to plug in 2 instead. So 2 squared plus v times 2. I'm just plugging and chugging. And then y is 0 when x is 3. Now, do we like it written like that, though? No way. But do you see what I did? I plugged in my x's and my y's 3 different times for my 3 different points. Plug it in. But now the name of the game is, why don't we make this look nicer so that it's nicer for us to solve, right? So first of all, I'm going to do some simplifying of each of these different numeric clues. And then I'm going to do some rewriting to make life a little bit easier. So this first clue, I think I can rewrite him to be 1/2 a, because 1 squared is just 1. Sorry, it's up on the ceiling. Plus v times 1 is just v, right? Plus v plus s is equal to 128. Okay, it's looking a little bit better. And then I have 2 squared is 4. 4 over 2 is 2a. Plus 2v plus s is equal to 80. And then I have 3 squared is 9. 9 halves a plus 3v plus s is equal to 0. So guys, it's like my x, y, z systems, just the variables changed. And I had to plug in some stuff to get my equations. Now, does anyone see, excuse me, anything that could make some of these equations a little bit easier? Yeah, we're not a computer, so why don't we do things like, hey, let's multiply everybody by 2. Because what's going to go away if I multiply this guy by 2? The fraction. What's going to happen if I multiply everybody, what do you guys think? Down here by, I wouldn't do 9. I was thinking 2 again, because then you can get rid of that fraction again, right? So even though this guy's not bad, it was just with that fraction a little bit messy. So I was like, let's make it nicer. So at the end of the day, Tony, I think this was your question. It took a little bit of work to get your system, right? But once you get this all solved out, a plus 2v plus 2s equals 256. 2a plus 2v plus s equals 80. And then 9a plus 6v plus 2s. With just a little bit of work, it's a lot nicer. And if at this point, guys, you don't like the A's and V's and S's, you could technically make it X and Y and Z if you want, if that makes it a lot easier on your brain. But at this point, aren't we just going to do our system with R1, R2, R2, and R3? But instead of eliminating the X's, guys, apply the system to this problem. It doesn't really matter what the variables are. The system remains the same. So who are we going to be eliminating first? Yeah, let's get rid of our A variable using R1, R2, and using R2, R3. Then after the A, we're going to be getting rid of the V. And then our last one is going to be S equals. It's just applying the system. Just applying the system. So I'm going to multiply everybody by what? A -2? Does that sound good? So negative 2a minus 4v minus 4s is equal to negative 512. Negative 400 and any mental mathers out there? 32. R2 and R3, ooh, it's a little bit nastier. What did you guys end up doing? I'm thinking I have to multiply the top by -9 and the bottom by 2. Or I guess I could multiply the top by 9. So 18a. $720, yeah? Because I'm going to multiply the bottom one by -2. That looks easier to me. A minus 12v minus 4s is equal to 0. I liked the 0. What are we doing every time, guys, when I'm multiplying my equations by different multiples, trying to get them to line up? What process is that called again? Good, elimination. Just doing elimination. Has anybody been checking my work? Is it looking good so far? I can make mistakes with the numbers too. Gracias, it's a plus. Whew. But otherwise, it's looking good. What's our system say? We got rid of the A's. Now we have 2 equations, R4, R5. It's time to get rid of the, time to get rid of the V's. So let's go after that V variable. It's all strategy. Using R4 and R5. I'm going to multiply this guy by 3. Sound good? Negative 1296. Oh, and I have that guy over there. Just a few of you, just because there's not a lot of time, but remember how this whole chapter I've been talking about computer programming and not the specifics of the code or the programming languages, but the ideas itself? Did you see how even if 2 equations don't match at all, there's always a systematic way to make them match? This leads into the computer programming, because in computer programming, the computer won't be able to know, or wouldn't know necessarily, the easiest way to code it, wouldn't know whether or not these 2 match, or whether or not I could just multiply one, like this set, I could just multiply one equation by something. The computer won't know. So the way to always make something match to eliminate is just to multiply each of them by the other. To multiply all of R2 by the leading coefficient of R3. And then, when you're multiplying them by each other, just make sure that one is opposite. You can always, with any system, any 2 equations, you could tell a calculator or a computer in the coding, be like, oh, always multiply by the other guy, and one of them multiply by the negative, the other one multiply by the regular. That will always, always, always make it eliminate. We don't do that because you guys aren't computers. We don't talk about it or do it every single time, but technically that's the way to make it work every single time, regardless of the numbers given. But in this one, we weren't a computer. We saw we could just multiply him by 3 to make him match. So we end up with negative 4s equals 576. Thanks, Adam. So when we go to do our row echelon form, I'm going to go ahead and steal, we have a nice equation right there. We have 1a plus 2v plus 2s is equal to 256. None of these are super nice, so I'm just going to divide all of him by -2, because that's a part of our trying to choose the first, and then trying to choose that guy. So dividing everybody by -2 would be v plus 3/2 z equals 216. And then dividing everybody by 4, a -4 would end up being 144. And there's our row echelon. Now it's easy, as long as you remember the step to finish this problem. Once we get it in row echelon form, what do we get to do every single time? Starts at the back and ends with the substitute. Once you have your system, time to back substitute. Your final answer after back substituting, we know the 144 is our initial position. Plugging back in, we would end up with, if I did mental math quickly, that'd be 72 times 3, which is 216. Is V 0? I think so. Because 216, yeah. So then plugging in 0, that's easy. Plugging in 2, that's 288. And then subtracting 256 and 288. A is -32, which happens to be gravity. -32 feet per second squared. What a nasty system with a nice answer. All right, kiddos. 47 was probably the beast of homework. That parabola one was pretty nasty too, as far as requiring multiple steps. But here's my question to you. Does our system still work? Yeah. And that's the point with computer programming, finding a system that will work over and over and over again. The last question that you guys asked about was number, help me out, 59. Hey, look at this. The timing is a little bit ironic. Super Bowl. In Super Bowl I in 1967. In Super Bowl I, the Green Bay Packers defeated the Kansas City Chiefs by a score of 35-10. Total points scored came from a combination of touchdowns, extra point kicks, and field goals worth 6 and 1 and 3 respectively. If you don't know anything about football, they're teaching you about. So 6 points comes from touchdowns. Comes from extra point kicks. 3 points come from field goals. They're teaching you if you don't know anything about football. The numbers of touchdowns and extra point kicks were equal. It seems like we don't know right away how many touchdowns, extra point kicks, and field goals there were, right? So maybe we could make this guy an X. Does that sound good? He's an unknown. Make this guy a Y. He's an unknown. And this guy could be a Z. So what did they just tell us if the touchdowns and the extra point kicks were equal? We're looking for a system. We need 3 equations with 3 unknowns. I have one just from the first clue. There were 6 times as many touchdowns, 6 times as many touchdowns as field goals. How can I write that? Yeah. How many touchdowns there were was 6 times how many field goals there were. Some people would have switched this accidentally as 6x equals z, but it wasn't that how many field goals were 6 times how many touchdowns. It's how many touchdowns were 6 times how many field goals. That one was a little hard to set up. Wait a minute. Well, what else do we know? What did all the points? Wait a minute. Did the number of touchdowns plus the number of extra point kicks plus the number of... No. How many points per touchdown? Good. 6 points per touchdown, 1 point per extra point kick, and then 3 points per field goal. All of that had to go up to, good, 45, the combined score. Does that make sense? They weren't talking about per team. They were talking about all together. So now what do we do? Yeah, it's up to you. Ultimately, we solve. So if you guys wanted to set it up like as an actual system, couldn't we do x minus y is equal to 0 if we wanted to get it all to one side? And x minus 6z is equal to 0? We have a couple different options, but I think how I would have done it, and some of you guys know football so well, you're like, I already figured out the right combination. Great job. Thomas Hurst did last year too. He's like, oh, it's this. I was like, good. My brain wouldn't have done that. So my football people, you can go ahead and play around with the scores and try to figure out how they got those points. However, you could solve the system just by doing like R1, R2 and getting rid of the x, because you could have done 6x plus y plus 3z equal to 45, negative 6x plus 6y. I'm multiplying everything by 6. You could have eliminated. Would have gotten 7y plus 3z is equal to 45. We could have taken the bottom two equations, done the same thing. X minus y is equal to 0. Multiplying by a negative, negative x plus 6z is equal to 0. So negative y plus 6z. What can we do with these two? Eliminate again. Then y plus 3z is equal to 45. Multiplying by 7, negative 7y plus positive 7, right? 42z is equal to 0. 7z? No. Sorry, that's a 42. I thought that was a 4z. Yeah, 45. Therefore, z equals 1. Haha! I got 1. Once I know z equals 1, what can I do? We can be creative, not a computer. We can go plug in, right? So if z equals 1, what does that mean x equals? X equals 6, and then if we plug in, well, if x is equal to 6, then y is equal to 6. You can double check it, but 6 times 6 is 36. 36 plus 6 extra point kicks would be 42, and 42 plus 1 field goal, 45. Whew! All right, cool kids. We only have 7 minutes to get into section 7.4, but we're going to do it. Remember, when you're doing homework, have your notes close. I know that the Super Bowl thing was a little weird. I know making your own system is a little weird. So those application problems, I totally expected those questions. But have your notes close for the math, getting the system down, because you need to have the system down. The basic foundation to how to solve problems before you ever get to the applications. Then when you got to the applications, you were supposed to be thinking, I need a system, then I can solve. I need a system, then I can solve. But good job having those questions ready. Section 7.4, partial fractions. Partial fractions. It is going to seem a little weird showing up right now. But it's going to be kind of a nice break, I think, for some of us. It's going to have a systematic approach, but it's not exactly solving a system of equations, or actually it is, but there are shortcuts to it. Technically, it is a system of equations at its core, or it needs a system of equations at its core. But there are other ways of tackling this. There are other tricks to help us do it without needing a computer. Here's the long story short to the idea. How could you guys prove to me that these two sides are equal? Do you guys agree with Adam? A little bit louder, Adam. Common denominator. Remember with proofs how we would choose the harder side, and the harder side was sometimes the fraction because we could always do common denominators to put them together. Or I should say the addition or subtraction of fractions. So let's use that idea. Add them automatically. It's like common denominator. Cool. Well, common denominator, what would I need to multiply this guy by top and bottom to make him match? Yeah. I already have an x plus 2. He's going to need an x minus 3. And this guy already has an x minus 3, so I'm going to need to multiply both of them by x plus 2. What happens when we do that? Struggle. Come on, smartboard. Do you guys agree with needing to distribute and getting 2x plus 4? Couldn't the bottom be FOILed out? I wonder if x squared minus 3x plus 2x, isn't that minus x? Negative 3 times 2 is negative 6. Over here I could have plus, distributing my negative 1, the same way we did our 2. Negative x plus 3 over, hey, it's the same pair of factors, so it should get the same thing. 2 minus 1x is 1x, and 4 plus 3 is 7. How'd we do? Good. But this section isn't about common denominators. This section isn't about going from this side to that side, even though right now this is all we can do. This section is about how to go backwards. Up until this point, it's only really been useful for you guys, for the most part, to go from an addition of two separate fractions to the combined, the simplified, the condensed form. Kind of like logarithms and exponents, the expanded to the condensed. Common denominators. It's only been useful to go that way. But here's the problem. As you get into higher math, there are actually times, especially in calculus, when it's useful to not just be able to go from smaller pieces that are being added or subtracted to one combined fraction, which is really useful for things like vertical asymptotes and horizontal asymptotes or oblique asymptotes. It's super useful to put it all together and look at one fraction. But sadly, there are going to be times where it's going to be super useful to go this also. This entire section is how to go backwards, how to take something that has been put together and figure out what are its most elemental, fundamental pieces that are individually simpler than that combined fraction. I can't fully explain to you exactly how or why. We're not going to be able to write this down today for sure. There is a system to it, but let me just show you in an example. I think we'll come back to writing all of these directions on Friday. Let me just show you an example of how this one that you just saw us go forwards, common denominator to get, how could we go backwards? Okay, let's take this example that you just saw. We'll write down directions and steps and all that tomorrow. The very first step to trying to do what we call a partial fraction decomposition, decomposing, breaking apart, breaking down, is to say, that denominator can be factored. Without knowing what it was supposed to be, even though you guys just saw what it is, you could have taken that denominator and factored it to be x minus 3 times x plus 2, keeping that x plus 7 up top, and saying, okay, that could have come from denominators of each of the factors. And then we could split this up and say, okay, each of those factors could have had a fraction. Now, here's the problem. We don't know, and we can't know just from the numerator exactly where A and B, the tops, could have come from. So what we're going to do is say, okay, I know this could have come from some sort of fraction with x minus 3 and could have come from some sort of fraction with x plus 2. But now, guys, I'm just curious. Can anyone see possibly how we could try to solve for A and B? And some of you are like, no. This is one equation, two unknowns. But remember the complex number thing? One equation, two unknowns, but really two clues. What would happen? Remember how we were trying to get rid of the systems of equations? What would happen if we multiplied both sides by the big old denominator? On this side, wouldn't the denominator go away? And you would just have x plus 7? On this side, when you distribute, wouldn't the x minus 3 cancel? And you would just have a times the guy who he would have had to been multiplied by to get the common denominator? And when you go to the b, the same thing would happen? The question we need to ask ourselves is, one equation, two unknowns that we're trying to find, is it possible? Possibly a question for tomorrow. You guys can go ahead and head to chapel. I'm going to actually finish solving this, guys, so if you're curious and wanting to start on homework, you can see how I do it, because the answer is yes. Bye, guys. Wednesday. Oh, sorry, I said it, but I didn't write it. Yeah, Wednesday. Give me 1 sec, Adam, you'll see it. Like complex numbers, some are x's, some are not. I get to set up. And I can divide this by x. I have my two equations. Complex numbers, the real and the imaginary, how you could split them up and say these are the reals, these are the imaginaries. We have two equations. Same thing here. Bye, guys.